Bukan susah sangat lah chi-square ini sebenarnya. If you know the concept, memang senang lah. Okay, now chi-square test. So many models are useful for illustrating basic Mendelian models, okay, or Mendelian genetics lah. Memang banyak model yang boleh kita guna, dan biasa yang kita guna untuk animal ialah Drosophila melanogaster lah, ataupun fruit flies. Kita pun boleh gunakan corn, okay, or sweet pea, or some other system. The basic principle are applicable to all diploid system, including humans lah. Right? Cuma humans kalau kita nak test chi-square ni agak lambat kerana dia menghasilkan masa yang lama untuk hasilkan progeny. Okay, untuk tubuh orang tu matang, hasil progeny lambat lah. But kalau fruit fly, sekali fruit fly ni bertelur sampai beribu. Okay, so senang. Sweet pea bersama, corn bersama. Okay, so contohnya kalau kita tengok di sini, kalau monohybrid di sini ialah dia hanya based on satu trait sahaja kan, sama ada corn itu dia purple ataupun yellow. Boleh recall tak ini?
Boleh.
Apa itu monohybrid? Ialah di mana kita tengok pada dia punya satu trait saja. Kalau dihybrid, kita tengok dua traits. Di sini kita tengok color, okay, color purple ataupun yellow pada biji dia, pada kernel tu. Satu lagi ialah whether it is smooth or wrinkle. That is second trait. So di sini kita ada corn with the kernel that has purple and smooth, yellow and smooth, purple wrinkle, and yellow to wrinkle. Boleh? So ini akan hasilkan 4 phenotype yang berbeza. Boleh ya?
Boleh, doktor.
Okay. So kalau di sini, kalau kita tengok possible hybrid crosses, kalau kita tengok di sini, so kita nak tengok apa yang akan berlaku nanti. So kita boleh gunakan Punnett square untuk hasilkan di sini juga. Ataupun nanti kita gunakan chi-square test untuk test dia. Okay. Contohnya kita tengok parental P1, okay, for the monohybrids. Kita cross dia, kita akan dapat F1, dia semuanya yang dominan. Tapi pada F2, kita akan dapati dia punya adalah berbeza. Di mana dia follow Mendelian punya ratio 3:1. 3 purple, 1 yellow. Okay, kalau kita tengok the hybrid crosses, kita dapati dia ikut Mendelian law yang kedua, di mana dia ada 9/3/3/1. Okay, di sini dia akan hasilkan 8 jenis phenotype yang berbeza. Okay, so one of the advantage of the Mendelian approach is that it is quantitative and may be tested mathematically. Okay, and the hypothesis is presented in a null hypothesis proposing that the observed data are the same as the predicted data. Contohnya for monohybrid, which is 3:1, or for the hybrid, which is 9:1, 9:3 to 3:1. So therefore, we perform the chi-square test, which is a statistical analysis to see if the data fit our hypothesis or not. So also called a goodness of fit test or the null hypothesis. So di sini, two values are involved. One is the observed value, which is the O, which is the frequency of a category of a sample. And the other one is the expected frequency, which is the E, which is calculated based upon the claim distribution. So formula dia ialah X square, kalau chi-square test X square ini kepada the sum of the O minus E to the power of 2 minus divided by E, whereby the O is the observed value and E is the expected frequency. So chi-square analysis cannot tell us a hypothesis correct or incorrect, only whether the observed result is good to fit with the predictions of the hypothesis. It won't tell you whether it is right or wrong. Right? So the difference between the result and the predicted are unlikely to be due to the chance alone, and the hypothesis will be rejected on another one track. So typically, if the probability of the obtain of the data observed, which is a chi-square ini, values is greater than the 5%, which is p value greater than 0.0.5, then the hypothesis is accepted. Other than that, it will be rejected. most of the time. So, for example, among the progeny of a monohybrid crosses, which is the R, capital R and small r, times to the capital R and small r, you expect that the 3/4 will have the phenotype of the R, and a quarter of it will be the small r, homozygous small r. So the phenotypes you observe and count probably won't match this ratio exactly because trans play a role in biological phenomena. So if you have a number of 120 progeny, we expect a third of it will be R, okay, capital R, which is dominant, which is 84, and a quarter of it will be a homozygous recessive small r. So suppose you counted 79 with the capital R and 33 with the small r or homozygous recessive r. So are your result close enough of this ratio for you to accept the null hypothesis that is no real difference? Okay, you want to see whether it is fit into the 3:1 ratio. There's no real difference. So the chi-square test is one tool for making this decision. So basically, chi-square is a tool to help you to test whether your hypothesis is rejected or accepted. So dekat sini kalau kita tengok, so we take an example. If one dihybrid experiments, this data was recorded from a total of 381 seeds with 216 round yellow, 216 round yellow seed, 79 round green seed, 69 wrinkle yellow seed, and 21 wrinkle green seed. So what is the ratio expected? Perform a chi-square test to validate the prediction. So your tentative hypothesis that it is this is a the hybrid cross, okay, and then you write the genotypes involving two pairs of heterozygous gene, resulting in an expected theoretical ratio of 9:3:1. So what you do is the next find the degree of the freedom. So degree of freedoms is basically the phenotype, the types of the phenotype minus 1. So you get the degree of freedoms. Okay, in this case we have four types, four phenotype. Okay, which is the purple and small, purple and shrunken, yellow and smooth, and yellow and shrunken. So this is 4 different phenotype. So your degree of difference is that the df equal to n minus 1. So you plug in the n is 4. So 4 minus 1 equal to 3. So far okay tak sekarang?
Yes, doctor.
Yes.
Okay, so yang you observe di sini, purple and smooth is 216, purple shrunken 79, yellow smooth 65, and yellow shrunken 21. So all of the number that you observe is 381. Okay, and your expected ratio is 9:3:1 kan?
Yes.
Okay, so macam mana kita nak kirakan expected number? So di sini is 381 times. Kalau expected for purple smooth should be 9/16. So you expect 214. Yeah. So purple shrunken is 3/16. So you expect 71. Yellow smooth also 71, and yellow shrunken is 24. Okay, based on the theoretical. But what you counted is 216, 79, 65, 21. So you want to see whether the one that you observe here fit or not. Boleh ya?
Boleh.
Okay. Okay. So di sini you letaklah dalam kolom 6 itu you masukkan nilai yang kita punya formula tadi itu, and you can see. Okay, kita punya chi-square value sekarang. Okay, the chi-square value di sini ialah 1.8. Yeah. You sum up in so you apa tu? Okay, 1.8 di sini. Lepas tu kita tengok di sini. Degree of freedom 3 kan? DF kita ialah 3 kan?
Yes.
Yeah.
Yes.
And then you tengok 1.8 dia di sini. Okay. Sama ada dia fit ataupun reject. If the calculated chi-square value is less than the chi-square value at 0.05 or probability level, we accept. which is we fail to reject the null hypothesis. Yeah, so if the calculated chi-square value is greater than the value of the table, which is 0.05, so probability level, then we reject the hypothesis. Therefore, because the calculated chi-square value is smaller, then we accept the hypothesis of the data which fit the 9:3 ratio. Boleh tak? Because apa yang kita calculated di sini ialah, kalau kita tengok 0.18, a degree of freedom ialah dia antara 1.8 ini, ialah, and then kita drag kan, kita bandingkan yang belakang tu. Okay, at 0.5. 0.5 nilai dia berapa? 7.82 kan? Nampak tak?
Yes, Doctor.
Apa saya tulis dah sini. So this is, okay, this is what we calculated kan? Ya? 1.8 ni yang kita dapati kan?
Yes.
Kan? Tapi in theory 0.05 tu ialah 7.82, betul?
Yes, Doctor.
Okay, so which one, so what, so the calculated chi-square value is greater kan? Or smaller?
Smaller.
Smaller kan? So kalau dia smaller, then we accept or reject the null hypothesis?
Accept.
We accept lah. Because in the table, the closest, sorry, let me drop it off. So kalau kita tengok, the closest dekat 0.18 ini ialah, but the degree of freedom of 3 is 1.85 kan? Is the closest number. So to go to the top of the column and then you locate your probability value. So in this case, our probability line up is 1.85 is 0.6 di sini. So this number means that the probability that your hypothesis is correct is 0.6 or 60%. So the probability that your hypothesis is incorrect is 40%. Maksudnya. And that's why we accept the null hypothesis. Maksudnya dia prone to lebih besar lah, because 60% is betul. Faham tak?
Faham.
Matematik kena pandai sikit lah ya. Di sini senang saja. Okay? So, I think habis lah. So, apa yang kamu kena buat di sini, you go and try the tutorial. Kita ada tutorial kan? Okay? Yeah. Kita ada tutorial, go and try the tutorial. And kita pun ada satu assignment yang Mr. Zachary ada keluarkan assignment 6 tu. They're very easy actually, that experiment. Dia punya assignment tu. It's just a free percuma saja. Kalau saya punya assignment dia tak senang macam tu lah. Tapi kerana kita kena ambil kira, kita ada program lain. Bukan semua pelajar smart macam biotech student. Ya, so kita kena ambil kira, ada program pelajar dia matematik yang lemah. So kita ambil means lah, kita ambil purata tu, and kita comes up with that kinds of question so far. Okay, so any other question? Are you with me?
Yes, Doctor.
Yes, Doctor.
Okay.
Yes,
So try it out. Try the tutorial. Then after that, mungkin kita boleh buat discussion nantilah. Okay? Boleh? You go try the tutorial supaya kamu lebih faham tentang chi-square ini. Right? You got tutorial 1 and tutorial 2. Basically, itu ada actually is saya punya class assignment actually. If we are physically we face to face, kalau class lah, okay, kita face to face punya teaching, then I'll ask you to do the assignment right in front of me. I give you 10 minutes and you figure it out and we discuss in the class. But too bad, because we are not in the class, so you just try it out later, because I don't want to use up too much of your data. And then after that, we try to do the discussion if you have any issue on it. Boleh tak?
Boleh.
Boleh.
So, kalau macam tu, good luck for your midterm exam. It's going to cover chapter 1 until now, and jangan risau, not too difficult. All MCQ. Okay? Jangan ask for tip, mas, saya tidak bagi tips punya. Okay, my tips are all class.
When,
Okay.
Doctor, may I ask when is going to take our mid-sem exam for this course?
Next Thursday during the class time.
Okay, thank you, Doctor.
2 to 4. Saya akan send the link to you nanti. Don't worry.
Okay, thank you, Doctor.
Okay, huh? So, if no more question, then we will end our lecture to now. Okay?
Doctor,
Yeah.
Doctor,
Yes.
I have a question. Just now, the calculated chi-square value is 1.80, right? And that's why we choose 1.85. And what if the calculated chi-square value is 1.43? Do we choose 1.42 or 1.85?
We look at the nearest, at the degree of freedom. Kita punya degree of freedom tadi kita 3 kan?
Yes.
Okay, so you go to that line degree of freedom 3. You choose the closest.
What if it's in the middle, like 1.6 something? Do we choose 1.42 or 1.85?
Tengok, you tengok nilai itu. See which one is the closest.
Okay.
See which one is the closest. Kalau 1.4 tu dia dekat dengan for example 1.45 dekat dengan 1.4. The next one is 1.8. Of course you choose 1.4 lah.
But if it's 1.6 something, then it's right in between 1.4 and 1.85, right?
Tapi belakang dia mesti ada nombor lagi. Dia tidak akan cun macam tu saja.
Oh, okay.
It's very easy. Kalau dia usually kalau kita tengok sama ada, it's very clear sama ada reject ataupun accepted because kita kena banding dengan 0.05 punya probability itu. Ya. Kalau you tengok whether it is 1.4 or 1.6 or 1.8 kan, dia still accept kerana the chi-square value yang theoretically itu dia jauh lebih besar. It's 7 kan at 0.05 kan.
Yes.
So it's not a problem whether it's 1.4 or 1.8.
All right. Thank you, Doctor.
Okay, ada lagi soalan?
Doctor.
Yeah.
I have a question, but this one is from the lecture before, regarding chromosome-autosome balance system.
Huh? Chromosome autosome?
About the Drosophila, the chromosome, like, because during the last lecture you explained the sex is determined by the ratio of X chromosome to autosomes, right?
Mm-hmm.
And then I go to search on Google. The total number of autosomes for the Drosophila is 8, right?
Mm-hmm.
Then, but on the web, I saw that the chromosome and autosome total number of chromosome is some of them only have 3. So I wonder how is it like the 4 plus 4 equals 8, or is it like 1 chromosome and 2 chromosome autosome?
You need to see the ratio.
It's not like the total lah, like you add it up.
It's based on the ratio actually to determine the sex, whether it is a female or male.
Also, you don't look at like you total up the whole chromosome.
It's different. Dia lain dengan human punya tau. Kalau human X memang perempuan, XY lelaki. Kalau you tengok zebrafish pun dia lain juga.
Also, we cannot see like you count the chromosome, not like that lah.
You can count it, but there is no the way they calculate is different. The way they determine it is different. It's a bit complicated actually.
Can I share screen if it's possible?
Sekejap, Can you hang on. Geraldine, is it?
Yes.
I make you host and you share screen. You can share now.
Did you see anything on the screen, Doctor?
Yeah.
This table is because I couldn't understand. Some only have 3, and then I count it like manually. Some only have 3. If it can survive like that.
Hang
Yeah,
on.
this
This
is my
one you get from Wikipedia.
Yeah.
You have to remember that Wikipedia is a not valid source. You know, some of the information could be wrong.
Oh, I see.
Yeah, some of the information. So, if you want to know more about this, then after midterm, then we talk about this. Okay.
Okay, sure then. Thank you, Doctor.
Okay. Ada orang nak attendant nggak siapa? Hang on. Too many. As funny Sonia. Okay. Siapa lagi nak attendant? As funny. Rohaizat ada tak? Rohaizat Adila tak ada? Macam tu tak ada. It's okay, class. Amiro already. Your menu attendant already done. Okay, so kalau macam tu, Geraldine, come back to me after your midterm. Okay, I will talk in more detail about that. Josephina punya nanti.
Okay, thank you, Doctor.
Okay, so at the moment, you jangan risau banyak-banyak. So make sure you really learn for your midterm. It's all MCQ. I still not too sure how many questions that I need to give it to you, because last year the midterm were 100 questions. I don't know whether this year I need to give you 100 or maybe 60 or 75. Okay, I still haven't finalized, but I'll let you know when I finalize it. Okay, because I need to log in the system and then do some changes. Okay, boleh ya?
Okay, Doctor.
Okay, then all the best to you and have a good day. All right.
Thank you.
Bye.
Thank
Bye.
you, Doctor.
Thank you, Doctor.
Doctor.
Thank you, Doctor.